Welcome to part 2 of our video lesson on solving two-step word problems about percent. In the first video, we looked at how we could go through the steps of the U-Pack method step by step to make sure we created a bar model, looked for missing information, made a plan to get to the answer that we needed, went through the steps of fraction multiplication or subtraction in some cases, in order to find the answer, and then we checked the answer using the bar model we'd already created and all the reasoning we'd already done to make sure that the answer made sense. Now we're going to look at more complex two-step problems that have 3 parts to make up their whole instead of just 2 parts. We're still going to be thinking about the idea of discount or budgeting as we come up with these answers. So let's look at this problem. Shri had $500. He spent 24% of his money on transport and 36% on food. We have 2 things we need to find. First, we want to find what percentage of his money was left. And then we want to find how much of his money was left. It's really important to separate percentages from countable quantities. $500 is a countable quantity of money. I could tell you how many bills I need to make $500. 24% is a percent of that money, but it's not a countable quantity. I don't know how much money there is. So let's start with the first problem. Look at our bar model for problem A. In that bar model, we've established that the total countable quantity is $500. And that countable quantity is divided into 3 parts. The amount of money for transport, the amount of money for food, and the rest of the money. We are looking for the percentage of that money that was left. That's why we have a question mark inside the box. Remember that we always know the total percentage because percent means out of 100. That's right. So we're going to start with 100 and subtract away the parts we know in order to find the missing percent. 100 minus 24%, then minus 36% gives us 40%. I know some of you are thinking, but couldn't I add 24% and 36% first to get 60% and then subtract 60% from 100? Yes, you absolutely can. That's the great thing about a bar model. The bar model shows us that we have a total and we're trying to get rid of 2 parts to find the other part. But you can do that in any method that makes sense. So we know that the total amount of money that he had left, that white part we see there that was left, is 40%. He'd already spent 60% of his money, but he had 40% left. Now, do we know how many dollars he had left? How many actual bills he had in his hand? Not yet. But we can use percent of a quantity to figure out how much money 40% of 500 really is. Now we're going to be looking for 40% of 500 because 40% of his money is what we're after. That's the part that was left. And 500 is the total countable quantity of money. So we need to find 40% of 500. In order to do that, we're going to translate our problem into math terms. 40% of 500 means 40 over 100 multiplied by 500. We know 500 and 100 can be simplified into 5 and 1 when we divide by 100. So we really just need to find 40 times 5, which gives us 200. So $200 was left. Now let's look at our thought bubble to look at a little bit more reasoning. How can we check our answer? 1 whole is 100%. Half of that whole is 50%, right? You know that. So 50% of 500 is half of 500, or 250. 40% is less than 50%, so we should be getting an answer that's a bit less than half of the total money. 200 is less than 250, so the answer is reasonable. When we check our answer, we go back to that first visual representation we created. We simplify, we estimate to see what we already know, and we compare the quantity we got to what we expect. We expected the answer to be just under $250 because 250 is half of 500 and 40% is a bit less than half, 50%. So we looked at our answer, 200, and we compared it to what we expected, a bit less than 250. 200 is a bit less than 250. so our answer makes sense. We were able to solve this multi-step problem by differentiating when we were looking for percents versus when we were looking for countable quantities. We have different methods that help us depending on what we're looking for. So it's really important to understand and draw out a problem before you try to guess or come up with the answer. Let's try another problem with 3 parts to make a whole. 600 people visited the museum last Sunday. 40% of the visitors were men, 35% were women, and the rest were children. How many children visited the museum? Now, notice this problem is a little bit similar to the last problem we had. We know the total quantity, we know 2 partial percents, we're missing one of the percents, and we're looking for the partial countable quantity of children. So let's go through the steps we did last time. First, let's try to figure out what percent of the museum visitors were children. We can do this by subtracting the parts we know from the whole. Now, how many whole percents do we have in this problem? 100, because percent means out of 100. You're never going to forget this. Percent means out of 100, okay? So we start with our total, 100, and we're going to subtract the parts we know. We know 40% and 35% were adults. So when we combine the men and women together, we get 75% of the people visiting the museum were adults. We don't want to talk about them. We want to talk about the children, those who were not adults. If 75% were adults, we can subtract 75 from 100 to figure out how many were children. So if 75% were adults, that means 25% were children. Is that our answer? Let's see. Looking back at the question. We always need to look back at the question. Just because we've computed doesn't mean we've necessarily found the answer that the problem has asked us for. So I'm going to reread the sentence with a question mark, and we're going to compare that to what we've already gotten. How many children visited the museum? 25%. No, we're not done yet. We found the percent of visitors who were children, but we haven't found the countable quantity, how many people were children at the museum. So we need to find 25% of our total. What is 25% of 600? When we're doing percent of a quantity, we always need to translate our problem into math terms. 25% becomes 25 over 100. The word of translates into a multiplication problem, and our total 600 stays the same, or you can translate it into 600 wholes. So now we have, now we have 25 over 100 times 600. We know that our 100 and our 600 cancel out to make 6 and 1. So what we're really looking for is 25 times 6, because that's what's left once we've simplified our fractions, okay? So we can count easily by 25s, or we can multiply. 25, 50, 75, 100, 125, 150. 150 of the people who visited the museum were children. All right, this is how we can work step by step, always making sure we're reviewing the question. We're reviewing our bar model as we go through to find our answer. And we only stop once we know we have solved the problem. The whole time we distinguish between countable quantities that answer the question, how many, and percents, which answer the question, what percentage. So we really need to look for those keywords in problems as we are solving 2-step equations with percents.